Greetings, we are Gustavo and Eduardo, and we are going to present our video for homework number 5, in which we will explore what QLearning is and give some practical examples. Now, before explaining what QLearning is, we need to go over reinforcement learning, which is a machine learning technique of unsupervised learning, which involves an agent and its environment. Now, the agent has to observe its environment and counts with a set of actions that are governed by a policy, which gives a reward based on the action that the agent takes reacting to its environment. Rewards are usually positive and follow the action of uncertainty states in case that the agent does the right action to keep exploring its environment. It has to explore what it can observe at the moment, and the agent will move throughout the environment, creating new conditions for the exploration and rewards and new actions. And as we can see, it's all a connected loop in which the agent performs an action and the environment in turn gives the agent a state and a reward, an X state and a reward. Now, following up, Eduardo will explain what QLearning is.
Okay, so DeepQ learning is a machine learning technique that comes from the reinforcement learning tree. And it is essentially what Gustavo just described, but in a more targeted way. So for instance, an agent must observe an environment in order for it to take a decision. And what we humans do is evaluate the possibilities, and then we take the most, the best answer that we can come up until that point. But in this case, the QLearning strategy, what it does is it simply takes a given state and it tries to associate a given action. And with that action, it comes a reward, and it evaluates how much of a reward did it get. And then after doing all of that, it sets a given value for that state. So in order to determine which action it should take. And the goal of the DeepQ learning modeling is to eventually model the whole environment or the whole map in which the agent is moving, for instance, the sandbox. And it is going to create an array or a huge map of states and actions. So eventually it should have a huge dictionary that basically describes the whole place in order for it to see a situation and then just look into what it's being coded in its history and answer accordingly. So basically, it's almost like having a function, and it needs to adjust the parameters manually. So it needs to go and to explore the environment and then to create the outputs for the inputs. So it's almost as if there was already a function in place and the agent is just discovering it. It's moving around the map and trying to find, oh, for this X, this is the best Y. And for this X, this is the best Y. And then after having all of that, then a huge map is going to be created and consolidated in the dictionary. And that is the thing that it is going to use in order to operate and move through the things that, through the events. And an important thing to keep in mind is that sometimes the agent tends to encapsulate itself into loops that it has already explored. So there's also like an alpha variable that is used in order to input like some randomness into the exploration ability so that it goes to different places, but eventually the alpha variable is reduced after each iteration so that the agent can convert into a solution and exploit the knowledge that it has and that it has been acquiring over the past. And that's basically it. That's basically what DeepQ learning, and in the case of Mario and in the case of Flappy Bird, it's the same thing. So it observes the things, it models, creates a map, and then it uses the map to move around and to operate. Very simple design.
Okay, now as Eduardo mentioned, we have two practical examples. First of all, I will show an implementation of QLearning, which is running on an OpenAI environment, which showcases a Mario Bros. Game, which is being played completely by a reinforcement learning model. And as you can see, Mario advances, taking different steps, and the model restarts after the character is killed, but the AI will always try to continue going right, since the policy that has been given to it indicates that the more to the right it goes, the higher the score that it will get. And it can explore the map multiple times. In this case, this one was trained for 500,000 iterations. Now, Eduardo will show the Flappy Bird implementation.
Okay, so this is the Flappy Bird solution that was done with reinforcement learning and the DeepQ strategy. And something important to keep in mind is that if this was trained using the visual representation of the game, it was very slow since, well, it's paced to the pace that the game has, so it cannot go any faster, and therefore it cannot learn really fast. But if the simulation is adjusted so that it flows really fast, then the algorithm can model the solution just as fast as well, since it's going to be moving with the time that it has been coded into the game. And well, for instance, if we were to train this with the visual aid, it would take a lot of time, but in order for it to hit 100 high score, like in a consistent basis, it took like under 3 minutes of training to get this progress. And yeah, that's basically what we did with Flappy Bird as well.
All right, I think that would be all. Thank you.
Thank you very much.